So hello, my colleagues in MBA 502. Uh, this video is concerning, in Chapter 5 on interest rates, there is an example here, 5.2, and I want to add a little more stuff to it because it could be confusing. So they're going to convert the annual percentage rate here to a discount rate. Okay, they're comparing whether or not to buy a phone system outright for 150,000 or to pay monthly payments of 4,000 a month. But the calculation gets a little strange, but I'm going to use Excel to show you how you can get these answers also, all right? So we're going to borrow the 5% APR. Now they give you an APR at 5%, right? It's an annual percentage rate, not effective. And now it's semi-annual compounding. And we got to remember we're dealing with monthly payments, so we got to get the semi-annual compounding with a monthly discount rate to a monthly discount rate. So we're going from a year here, right? A year, and we know we have to deal in monthly payments, and basically we have semi-annually compounding. So what we've got to do is divide this by 2 to get 2.5%, which is the rate for a 6-month discount rate. Again, we don't have EAR here, right? So we have a 2.5-month discount rate. Now, what we've got to do is we've got to get this rate here, the 6-month rate, into a 1-month rate. So we've got to compound the 6-month rate by 1/6. Now you don't divide by 6, all right, because it's compounded, all right. And you see what they say here. And this is where it gets a little messy. It's semi-annual compounding, okay. So this is where it gets a little messy, okay. So we use equation 5.1, and 2.5% every 6 months corresponds to 0.4124% every month. Okay. So again, let me see if I can get up to equation 5.1 here. Just give me 1 second. I think I got to go back a little bit. I got to go right to here, right? Equivalent end period discount rate. So they put the 2.5%, right? In there, right? And N in this case would be, let's go back here. We'll take a look at that. So here's that equation. N is 1/6, right? And again, this doesn't have to be a whole number, as you can see, right? So here's the quarter for right, quarter rate. So that corresponds to 0.4124% per month. So this is a 1-month discount rate. All right. So there's compounding involved here, right? Every month to get to 2.5. Now there's another way of looking at this. We could have basically used equation 5.3 up there and converted the 5% to an effective annual rate. So this is where it gets even a little more confusing. So I could have taken that 5%, divided it by 2, right? And then squared it. And that corresponds to an effective annual rate of 5.0625%. Then we can convert the EAR to a monthly rate, again using equation 5.1. And you can see it comes out the same way. Comes out the same way. All right, so anyway, the present value comes out to be this amount of money, and they've come up with this present value using Excel. You could use this equation here, which is 4.9, or you could use Excel, and you would get the same number. Okay. All right. So why am I going over this again? Is because I want to show you how you can come up with this number by doing an amortization table in Excel. So that's what I did here. So remember they told you this was given, right? The payment was given, 4,000 a month. Actually, let me do this. Hold on. Payment, Given. Given. Okay? So that's given. This is given, right? And I want to show you, my goal is to show you how they got this number. And this is given. So you take this number here, this interest rate every month, and multiply it by your, basically by your balance. First of all, you multiply it by this balance, right? So basically what happens here, we got this table of all 48 payments of $4,000. All right, so the first thing we have to do is we want to determine how much interest we have to pay the first month. We got to start paying interest on this loan, right? So I'm going to click on here, and you can see if I click on here, I wrote G4 times G2, and all that is I'm paying interest the first month on my total balance here of 173,867. So if you multiply these two, you're going to get this, right? 717. Now, if that's interest, and this was my payment, the difference, as you can see, I just subtract here, is the principal. So I take this principal and I subtract it off of this, which you can see right here is what I do, G4 minus B3. And this is my new balance. Okay, now I got to keep doing this, but now I got to basically take D3, which is my new balance, again times G2. So I'm going to hold G2 constant, right? This is constant. And this is my new interest. And again, I subtract that from there and I get this principal. So I now subtract this from here and I have my new principal. So you can see D3 minus B4. Okay. So anyway, so I keep doing this. Now there's a scheme and I just keep doing this. And you could just go down the list and you could keep seeing me do this, right? And you can see the pattern after a while here. And the balance goes lower and lower and I pay more and more principal. Again, this is for 4 years. So I get down to the very bottom. So here's my total payments, right? 48 times 4. I made $192,000 in payments. Okay. And if I add up the principal, so here's the principal. If I add up all the principal in this column, which I did right here, watch. Sum B3 to B50, I get 173,867, which is exactly that. Okay? So you can see how that works out. And then here is the interest I paid. C3 to C50, right? So I paid $18,000 in interest over the 4 years on a $173,000 loan. Okay? All right, so just to show you how I can get to 0.4124 real easily, they were using equations. I go over to here, and this is the rate function in Excel. And again, here's 12 periods, right, for the year. And I have a $4,000 a month payment. And here's my present value, which is right over here, right? And after 12 months, what's left is 133,565, right? This is the 12th month, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, right? So that's my future value, right? And you can see it comes out to 0.004124, which is exactly that. And when you convert it to a percent, and then you can take that and again go back the other way, take 1 plus I6 to the 6th power. I use the caret symbol, minus 1, and I get 2.5% for 6 months. All right, so I just wanted to show you how you can do that problem in Excel. All right, everybody, take care.